Now entering the Shark Tank, Dr. Jason Leng of Washington State. He has developed a portable, low-cost vitrector.
Hello, everyone. I have a PowerPoint. So this journey has really been a testimony of how God's worked in my life, so I just wanted to share the journey and the process. So it's been a burden on my heart for many years, high-speed vitrectomy in the mission setting. About 2 years, I spend as much time as I can in my vacation to go on missions. About 2 years ago, or maybe a year and a half, we were coming back from North Korea, and there were some cases, complex cases, the sublux lens and stuff. I really wanted to do more, but we didn't have a vitrectomy, and it just bothered me. It's like, I really want to do more, and I need to have some type of vitrectomy solution for complications and also complex, and to do more in-depth cases. I wanted to handle things better than just a scissor vitrectomy that we've been doing for years, and I started looking. All the available machines were either the size of your fridge, also really, really expensive, and most of them are both. So I went to look for more portable and cheaper solutions, and the only couple I found that were available on the market was one made in India, the one on the left. So I went to the booth at Academy, at Apasami, and they had a machine there. So I kind of asked them, and they're like, oh, it's not really for sale for India, but some for people who want to do mission stuff. That machine was about, this big, like an old 1990s PC, maybe bigger. There were some limitations. The cut rate was only 600 cut rate. And I said, where do you get your handpieces? And they're like, we don't manufacture handpieces in India. There's too high precision. They're all imported, US or Europe. So I kind of put that on hold. Then the machine on the right is actually a small, nice portable machine. It's electric driven, and a small company by Insight, and this was called the Intractor. Maybe you guys have heard of it or seen it. But the cut rate was about $12.50, not bad, but that was one limitation. Also, the cost was a little bit high. It was close to, almost $10,000. Maybe you get a discount if you're a missionary. The handpieces was what bothered me the most, because it was proprietary. You could only get it from them, and it was a small company. I'm like, well, there's going to be support. And I just checked yesterday, and they sold the company to Oculus, and it's not even listed anymore. So I don't even know they're making it. So it was kind of good that I didn't venture and invest in that product. The machine we have at home for phaco and anterior vitrectomy is an older machine. This is a Sovereign Compact Unit by AMO. It's a machine I use on a daily basis. And the vitrector on that it's an electric rotary cutter that cuts at 600 cuts. And it's really not ideal. Even I always felt bad when I had complications. I had to use a vitrector even at home. The probes are really large. They really wouldn't fit through a paracentesis. Cuts are slow. The handpieces would fail, and they're really expensive. Even an old handpiece like that was $1,000 to $2,000 to get a replacement. And most of the vitrectors at the time when I was looking about 2 years ago were at this style. Pneumatic driven, guillotine style. Most people are very familiar with this type of handpiece. So I was like, there's nothing out there. So I decided to take a leap of faith and venture to build one. I'm like, am I crazy? On my wish list, I wanted something that's high speed, a guillotine vitrector, that's something that I can carry around, is portable, and has a good support where I can buy disposable supplies, reusable supplies, and for handpieces and such. And I love this quote, I can do all things through Christ who gives me strength. And I'm not quoting this in a presumptuous way, because I know that I won't ever be able to lift a car, but in a more of an open way, where in Isaiah it says, here I am, Lord, send me. I'm willing. I don't really know how I'm going to do it, but I'm willing if you can empower me. Now, just give a background. I have no engineering background. I'm a biology major. When I was in college, I was kind of useless, right? I have no idea how they work. I don't know electronics. So these are the things, my barriers. I needed to study how the guillotine vitrectors work. I needed to study how electronics and circuitry work. The only thing I remember was like Ohm's law from physics I studied for the MCAT. I didn't know, I'm not a programmer, I didn't know computer code. I knew I had to write some kind of software. I didn't know about pneumatics. I didn't know machining. I didn't know how to use CAD. I didn't even know what kind of parts are out there. But thanks to YouTube and Google University, I felt that I could learn anything, you know. So this is a journey. And maybe I was biting off more than I could chew. But I showed a series of pictures yesterday and I talked about thinking outside the box and then going on these mission trips, and, you know, watching Dr. Jacob operate, doing something with almost nothing kind of inspired me to do something more. So I started working in my office. Now I had bought some eBay microscopes for missions, and they were just stored in my office. Everyone passing my office would laugh at me because I had these, I could barely walk in my office. Had these scopes. I'm like, well, since they're sitting here and I haven't used them, I'm also using them for learning how to solder circuitry boards. So I started just practicing soldering pins, reading a lot online about how to code electronics. So this is about late 2016. So we came back from our North Korea trip in September. So I started working on it soon after, about a month or two after. So after long days of work, I would just stay late nights in my office and just keep working when everybody left. About a couple months later, I came up with my first prototype board. So, like I said, no background experience. I'm like reading forums, tutorials, trying to figure this out. So this is my very basic board, and I had to solder every connection by hand. There's no printed board because it's all concept. So I wanted to make it small and portable. So I, bench, and I don't have access to a lab. And maybe I should have reached out to the hacker community or friends, but I'm more of an introvert, so I was like, okay, I got to do this all myself, So I was just doing this just in my office and at home. So this is my first prototype, and I had to put it in some kind of box. So I had an Altoids box laying around, so I stuffed it in that, and I realized that first that the Altoids box is metal, so some of my first prototypes got messed up because it wasn't grounded properly. So. You have that up phase, and you talked about the down phase. Yeah, there's a lot of down phase where like, oh, that didn't work. But so this is my initial prototype, and it looked kind of ridiculous. There's a whole bunch of tubes and gauges and power supplies and wires, and I'm like, I have no idea what I'm doing, but I'm learning, and God's teaching me. So actually, I wasn't going on a mission trip for several months, and that burden, I was starting to do a lot of complex cases at home. Trauma, cataracts, sublux lenses. I was doing pretty much secondary IOLs, glued IOLs, skull fixated IOLs on a weekly basis. And, there's vitreous in the AC to begin with in a lot of those cases, and I just felt bad using that old 600 cut rotary cutter that just seemed to be just winding up the vitreous in the handpiece, So I told the staff, I was like, I've done a lot of testing, I'm going to bring this into the OR. So I just take this whole pile of tubes, plop it on top of their phaco machine, and at that point, it wasn't quite refined yet. I had two pedals, one for the phaco and one for fluidics. And the second one was to run the cutter. And we actually did a few cases, and it worked great, thanks to God. Then I kind of moved my office work so I could work at home more. So here I am working. This is my kitchen counter. So I think I'm soldering a circuit board there. And so there's a lot of stuff I've just been learning and working on my computer. But God's really taught me. I didn't want to spend thousands of dollars on CAD software, so I was like, Google, what's free CAD software out there? So I downloaded like 5 or 6 different CAD software out there, and some of them were way too complicated, and I found one that actually worked. So finally I just, found a box that I would use and had learned how to machine, how I can give instructions through the CAD to the machinist to be able to cut custom holes and that kind of stuff. I learned how to design a circuit board, and so this is my very first circuit board design. I got manufactured here in the US. And when I was walking, I think I was in Academy or ASCRS, I can't remember one of the meetings, a few months later. Then I walked past the Alcon booth and the Constellation, nice, crazy expensive machine. And so they're comparing the Ultravit probe to the Cruise probe. And they called it port optimization, where in normal guillotine cutters, you would close the cutter and open the cutter. So you have a 50% when the time of the cycle when it's closed, and 50% when it's open. Okay, so that works, and that's how most of their anterior vitrectomies on your phaco machines work. But I wanted something more, since I'm already spending the time, I also make something good, So they called it port optimization, where you can stagger the cut, so you can see on the right side, the port is, that is an open biased port optimization, okay? And the other one is just 50-50, okay? So I decided, well, it's just a matter of code. So I struggled with the code. Again, I'm not a programmer. This is the first time I'm learning code. Programming, and I was like, finally I found, what the timing was. So I came out about a 70-30 ratio, and I might have switched it to 60-40. So, and the reason why you want to have an open port bias is that you can speed up the efficiency of vitrectomy because you can open, aspirate more material, and cut. But you can still have a high cut rate. So for retina specialists, I'm not a retina specialist, but what they say is, if you're going for a bulk vitrectomy, you want open port bias, and if you're really going fine-tune shaving near the macula or something, then you want a closed bias where majority of it's closed so that it's very fine-tuned. Again, no testing equipment. I had to test all pressures, everything by trial and error. I hooked up my iPhone. I wanted this high-speed camera to be able to visually confirm that my testing was correct. So I was like, where am I going to find a high-speed camera? I'm going to maybe rent one. So I'm like, wait, my iPhone has high speed a little bit, right? So I'm like, okay, I clamped the vitrectomy handpiece and focused my microscope on my office, and then put my iPhone and then hold my breath. And 240 frames per second, I can slow down 10 times. Then I could confirm that the cutter, and this is in slow motion at 2,000 cut rate, that the cutter was actually completely closing and opening. And you can kind of see, let me repeat that it's a staggered cut. So it's a open port bias. So this is, okay, so mine end of September, my first kind of prototype-ish made by March. And then this is my first mission trip, 2017 in Guatemala of May. Brought it there and it was working. At the same time, my boss is also a really big innovator, and he has way more knowledge than I did. So I was like, look, and I kind of wanted to keep a secret from him. And then, so finally I showed him. I was like, this is this machine. And what I actually had done is, since our phaco machine was had an old-fashioned cutter, by trial and error, I was like, oh, there's a serial communications port out of the back of my phaco machine. So I bought some cables and hooked up to my laptop and tried all sorts of things, and they just pumped out a bunch of numbers, but finally I was able to decipher like what number was actually meaning what. So in my first version, I had built in the software to communicate with our current phaco machine so that I could plug it in, bypass the old rotary cutter, use my high-speed 2,000 cut per minute cutter, guillotine cutter, and still use the fluidics on our phaco machine. So here it is on the left side, just put it on the side and hook up the serial port, and it would communicate. So my boss got excited. We have about 30 ORs in 6 different states. And so he's like, let me see. So I shared with him the design. So he's like, he loves building. So he built pretty much the primary parts are based on the ones I've chose. He wanted to do his own software design because the code, but the core components are about the same. So we have one in every OR, in I think about 30 of our ORs, which we are using on a daily basis for almost a year. So I refined it a little bit more. I had to learn a little bit of design, silk screening. I got some inspiration by Apple to make it simple. I wanted it nice. It's a one-body anodized aluminum body with caps on each end. It's only one knob. There's only one connector that anything can fit into, and its simplicity is key. There's one light bulb, and I'll show you how it works. So it comes in a case like this. It's very light. Runs off a portable air compressor. I wanted something quiet, and I actually found that compressor when I was daydreaming at 3 in the morning, trying to find a good air source that wasn't really expensive. And I just thought of it, and then I gave me an idea at 3 in the morning. So this will actually, my unit will actually run 110 to 240 power. Unfortunately, the The compressors are AC. Sorry. Compressors are AC, so that you can either get a 240 or a 120 unit. So this is, get this out of the way. I wanted to make it really easy, so quick release on everything. Plug it in, snap. You can get a longer cable if you wish. So the port in the back is just air, a reset button, and power. So you notice the light is blue there. There's only one light bulb there. There's actually a pressure indicator. Now the compressor's not on. Blue means it's too low, the pressure. So it's so these pedals I got and actually custom built the wire into them. So these are run off of guillotine vitrector cutters made by Midlabs. Midlabs, anything that looks kind of like this classic style like this is made by Midlabs, even though Alcon or AMO or other companies have it branded. They're all made by the same company, they're just sourced. Okay? So usually on your vitrector cutter, there's green you connect to the machine. So you connect it here, and then turn on the compressor. Very quiet, you don't really hear it, right? So now the light turns green, okay? So what happens when the pressure is too low, like for some reason, this should always stay constant. It goes too low, automatically turn blue. That's pretty easy. Okay, what if it's too high? If it's too high, then it'll turn red, okay? So it's very easy just to look across the room, and when it's green, then we are good, okay? So there's, you know, I originally wanted to have a bunch of settings with a screen and everything, but I figured it's more robust, less things that can go wrong. So I only have 4 speed settings, and I don't really see a need for an emission setting to need more than 4. There's a 100 cut rate for PIs and that kind of work. There's 600, 1200, and 2000 cut rate. And the reason why I would use a slower cut rate would be to cut like membranes and like fibrotic capsules. It's kind of like a Simcoe vitrector. So you just hook up, obviously you wouldn't use a syringe this big, right? This is the one I had laying around. Hook it up, you can Simcoe to the port, you step on the pedal. You really hear it because that's a 100 cut rate. Hear it all the way up to 2000 cut rate. Very quiet. It's cutting at 2000 cuts. And as long as it stays green, it should be good. And even though Midlabs makes all these, every manufacturer likes to make it proprietary. So it will work with Alcon, old Alcon Acrus handpieces, which they don't make anymore. I had a whole bunch. You just have to cut the connectors and re-splice them, but it's very easy. And the pressure is a little bit different, and you can just dial the pressure, whatever you want. So let me just give you the specs again for the machine. One piece anodized aluminum, quick release connections, cut rate max at this machine is 2000. It's actually limited by the handpiece and not by the unit. If it's all software, so I can actually make this thing cut at 8,000 cut rate if I wanted to. But the handpieces that are 8,000 cut rate are actually really expensive, so I don't really think there is actually a need for anterior vitrector. That's that high rate. 1,200 and above is plenty sufficient. This unit is light, but with the compressor and the pedals and everything is about 10 pounds. Unfortunately, the case that you can just throw around is also 10 pounds, so it ends up being 20 pounds. You know, I might be looking at lighter boxes, but one of my partners took one of my other prototypes to South Sudan just a few months ago. I brought this machine to Guatemala just 2 months ago, and we were able to do stuff that we've never done before. I did about 5 pediatric cataracts, bilateral, able to do posterior capsulotomies primarily after we did implant lens, complex cases, sublux lenses, and so it's a very useful machine that I found that has really opened doors to mission work. So, and again, vitrector handpieces you can get in 23 gauge, 25 gauge, 20 gauge, probably 20 gauge. 23 is probably your choice for mission work because they're cheaper, and you can 20 gauge will actually aspirate faster because it's a larger bore. That's it. Thank you.
I'd love to see a genie. This is amazing to think that this was done with an engineering background, and having worked with development of products similar to this, we needed 13 engineers and 13 doctors together to figure out how to do this. And Alcon, just so you know, just to do their constellation, used 3,000 engineers. But as you were talking, this history of vitrectomy surgery came to my mind, because Bob Mocklemer, and Steve knows about this, went to his garage and developed the first vitrector in his garage. And the first trial of the vitrector was with a pen that had a rotary cutting blade inside, and he needed something to try it on, and he did it on an egg. And of course, what Jean-Marie Perel did, of course, in engineering and developing the OMS and what we later on came to know as the vitrector, it was phenomenal. You've been able to accomplish this in 2 years. So this is not a minor accomplishment, it's big. My caution is that it is so good that you're going to have to face the FDA at some point and the patent offices. So you need to be prepared for monstrosity of obstacles along the way, unless you figure out another country where you can do it.
I want to say, wow, thank you. That is excellent. In the mission field, as you know, we commonly have a lot of barriers with regards to language and educational process. And as surgeons, we are typically in operating microscope mode, and we're staring through those, and we're not really looking at red, green, or blue lights. Is it possible to add some kind of a little noise component so that when it flips from green to blue or green to red, we are alerted? We're used to that. Our ears are trained to that. Is that going to add cost? And I don't mean that it should do that, but it might be helpful for mission settings where we have some language barriers.
Oh, that's very easy to do, and it'd be very cheap to do. I don't like annoying noises most of the time. The reason why there is even light to begin with is it's actually not that necessary. The tolerances are actually pretty close. So if it's green before you start, it'll stay green all day, okay? And you'll know when it doesn't cut, it just won't cut. And the compressor won't build more pressure than it's built. It might do lower if it's not working, but the moment you step on the pedal, you'll see the knife is not going. So there's not any danger to the patient at all. It's a matter if it works or not, but it's easy just to look across the room before you start, you sit down and it's like, oh, it's green. That's all you really have to do. Most of the time it's under the table. I don't really care anyway. It's when it doesn't work, then you're like, oh, okay, it's blue. The compressor maybe got kicked and unplugged or something, or then you know. Yeah. Mm-hmm.
Well, I must give you a standing ovation. No, it is amazing. Just to what praise God. I praise God.
Yeah, praise the Lord.
For the insight, for the skill, and for the passion that He's put in you to do this, right? And it's very special. Everything of your slide, I could see the struggle behind even getting at different points. And one of the things that's deeply touched me, I would definitely say what's really inspired me today is what I'm also going through right now, is that you learned something that is not even in your domain. And you went the distance, you learned it because on really and I only wish you the best as you scale this, as you take it into each and every OR to benefit millions of patients in the days to come. Other thing I wanted to ask, which Yuan also kind of mentioned, is of course there will be obstacles on the way because it's absolutely not easy to build a hardware device to get it to the stage, and your detail for design and usability and everything is really inspirational. So I really praise God, thank God, and I wish many, many more innovations come through the work of your hands.
Thank you.
Congratulations.
Thank you.
Yeah. The one I built worked nothing like that at all. I mean, that's just, it's mind-blowing what you've done.
Yeah.
Or one question and a comment, maybe, or a hope. Are they available to buy and cost? And the second one is, do you have any kind of a video tutorial where you can show the things you're doing and how to use this and set it up, and that would be real helpful as well.
Yeah, I didn't know how much interest people would have on this thing because I built one for myself, and I was talking to my sister who's also an ophthalmologist, and they're like, well, I feel like I can serve better, but then they're like, well, maybe the other people might be interested, you know? And I was just afraid. And it's like, if I make 10, make 20, and sitting around my house doing nothing. So the cost will be definitely related to volume. I really wanted, you know, I didn't do this for any money. I just wanted to be able to provide something to have people have a tool to give better care. You know, most of the machines are probably almost $10,000. I'm hoping, I'm still, you know, parts are from Europe, from all over the world. Hopefully I can get it down to somewhere between 2,000 and 3,000. And that's the goal. And still, you know, figuring that out. Of course, you know, all the not fun stuff is all the paperwork and working on patents. This will be, I was like, oh, this is kind of exciting. I get to file my first patent. And FDA, I'm looking into FDA approval as well, but that's not the fun part.
But something that I would definitely say is that I think you should seriously start off looking at equipping yourself with people who are focused on doing those things.
Yes.
You will probably find very passionate people who believe in the cause. I'm pretty sure the Lord will help you find those people. Because as an innovator, what I see usually happens is that you get caught on to all of these other things that is not your domain and your expertise.
Yes.
And that will suck your energy, and you will not be able to actually focus on the true innovation and making it better. So I think with immediate effect, the moment you get back from cost, that's what I mean.
Yeah, that's very helpful.
I think you should really look at people. I'm happy to work with you to help you kind of find resource or probably see if there's people interested to help you design, because people did that for me in Oxford. The Lord put people around me to help do that, and I'm very happy to work with you to probably help you chart that path out of how many more people use this.
Yes.
There is a lot of need for this. Never ever think that there is no one who will.
Just an idea, who would be interested in a machine like this for a mission? Okay. Gotcha. You know, the first name, I call it the V cube, the vitrector cube, because it was a cube. That's the only thing I could think of at the time, so.
Yeah. How many want to buy stock in his company?